So we're going over the homework on page 4. Where does it start? 401. And we had a question on 35 through 40. I'm going to look at 36. So 36 is asking us to solve the equation secant x equals 2.4 over the interval from 0 to 2 pi. Or I'm sorry, to pi over 2. Sorry. And it says to use a calculator to do it, which is great because this is not a ratio I'm used to. So secant x, I don't have secant in my calculator, so I'm going to instead solve this equation over the same interval. Are we okay with that? Because secant is the reciprocal of cosine. All right, so I'm going to go ahead and get my window set up before I do anything else. And you know what? I think I'm going to go ahead, since I'm only interested in answers between 0 and pi over 2, I think I'm going to use that to set up my x values for my window. So I'm going to say my x min is 0. And my x max, I'm going to type in pi divided by 2. Now, as soon as I move my cursor off of this, it's going to change that into a decimal, but that's okay. And my scale, I don't really care what the scale is. I'll leave it there. Looks like it's pi over 2 also. And the y min and the y max, as long as I'm going to show 2.4 in there someplace, I should be good. So -4 to 4 will work for me. I'll just go ahead and leave that there. And then I'll type in my left-hand side of my equation here. So 1 divided by cosine x. And then I'll type the right-hand side of my equation for y2. So we learned way back in chapter 1 that anytime you're solving an equation, they ask you to do it with the calculator. One option is just to graph the two sides of your equation in y1 and y2, and then you're going to be looking for intersections. So the only thing that makes this a little bit different from that is that they told us we specifically are only answering or looking for answers between there and there. So we'll let this thing do its business here. So that kind of reminds me of secant. It's kind of got that curve going up, and I do see one intersection, so we're only going to have one solution. We'll do second calc intersect. Get it pretty close, hit enter 3 times, and it'll find it for you. It's coming up with about 1.14. Did they tell us how to round? They did not. I'm going to say x is about 1.14. So the key to doing these is to set up your window so that it's only showing the interval that you're interested in. Type one side of your equation in for y1, type the other side in for y2. Look for intersections. I believe some of these you're going to see more than one intersection. 40 has 0.3. There's at least two. Did you get 2 different answers for number 40? Did I ask you to do 40? You got 2 different answers? Okay. Yeah, so some of these are going to give you more than one solution, depending on the interval. Okay, follow-ups to that? Any other questions we can go over from homework you had asked about, and I asked you to remind me and I've already forgotten. Was it 8? All right. 8 or 9. Does anybody have a preference on 8 or 9? I'm gonna go 9. 9 looks a little bit more complex to me. All right, so we got, what do we got? Y equals 2 times the cotangent of 2x. It says, describe the graph of the function in terms of a basic trigonometric function. Locate the vertical asymptotes and graph 2 periods. In terms of a basic trigonometric function. So that's a little vague. Who looked up answers in the back of the book for these? Were they describing transformations? Okay. So I think what they're asking us to do is to look at this and say, okay, well, this is, This is just cotangent x, but there have been two transformations done to it. What's this 2 doing on the outside? So this is cotangent x with a vertical stretch by 2. And let's talk about this 2 right here. Horizontal shrink by 1/2. So we can use those transformations, or we can kind of use what we learned before, or what we learned on Monday. So I'm going to graph cotangent. They asked us to do 2 periods. And on Monday, I asked you to either be able to reason your way to finding what a period of tangent, cotangent, secant, and cosecant look like, or be comfortable enough putting sines and cosines together to make them. For me, I feel like it's easier for me to just memorize what tangent and cotangent look like. So that's my strategy. But you do you. So I'm trying to remember now that I said that what one period of cotangent looks like. Now tangent 0. So cotangent's got a asymptote. So cotangent, if this would be my unshifted one, unstretched and unshifted, would go through one right here, would have an x-intercept here, it'd go through one here, and there'd be vertical asymptotes at 0 and at the end of the period. So cotangent's the one that looks like this. I'm like 95% sure. Does that look consistent with what you got in your notes from Monday? All right, that's one period. So I'm going to go ahead and graph another period. And same idea. So it's going to have start here. There'll be another vertical asymptote here. And the next intercept in the middle. And it'll kind of hit that point at 1 and 1. And normally, if this was completely unshifted and unstretched, we learn that the period of tangent and cotangent are what? How far before they repeat themselves? At pi. So this would be pi and this would be 2 pi, right? If it were not shifted or stretched. And this would be these special points in between where it hits 1 and -1, that happens at y coordinates of 1 and -1. That does not match what we've got going on though, right? This would be if it was just cotangent x. So rather than go back and draw everything again, let's just fix these so that they match what they should be. We said it was going to be a vertical stretch by 2, so this is no longer going to be 1 and -1. What's it going to be instead? 2 and -2. And we said it was going to be a horizontal shrink by 1/2. So that's not going to change 0, but it is going to change these. If we cut those both in half, we're going to end up with pi over 2 and just pi. So there we go. We got it graphed. So this is kind of last Thursday when you guys did your excellent job with those applications. I gave you some homework problems where I was kind of telling you, just go ahead and sketch the thing and then label it after the fact. That's what that's gonna be our strategy for these. Question? Oh yeah, it says locate the vertical asymptotes and graph 2 periods of the function. So it didn't ask us to do zeros, but I like the question. I'm going to go ahead and add that on. Okay, so let's do the vertical asymptotes first. So we've got vertical asymptotes here. So you kind of want to look at where does the first one happen, and the first one happens at 0, right? So x equals 0 plus. And then it's going to be something n, right? I just have to figure out what am I adding on each time to get to my next vertical asymptote. So started at 0 and then I added on pi over 2, 1/2 of pi, right? And then I added on another 1/2 of pi and another 1/2 of pi. So it's going to be 0 plus pi over 2n. And I would probably leave the 0 out, but it's fine. And at this point, I'm okay if you leave out the whole like n is an integer piece of it. If you want to just kind of get used to this idea, I'll know when I see an n in your answer that that's what you mean. That'll become more important next chapter when we're solving more complex trig equations. Are we feeling okay about vertical asymptotes? All right, and then let's go through and do zeros also. So look at the graph and tell me, where's my first 0 happening? It's happening right here. That's halfway between 0 and pi over 2. So half of pi over 2 is pi over 4. So there's my first one. So I'm going to write pi over 4 plus something times n. And I'll ask myself the same question I did just a second ago. How far do I have to go before I see my next 0? And it should be the same thing, right? Because pi over 2 is the period. That means every feature of this graph is going to repeat every pi over 2. That's the period tells us how often things repeat. So this is also going to be pi over 2n. And again, if you want to leave this, I'll put this in a different color. If you want to leave this off, that's fine. Not this. So the question was, do we need to put this n as a member of the integers on our test? Not for chapter 4. Chapter 5, yes. Not for chapter 4. All right, other questions from the homework before we get into new stuff? So last class I gave you full sheet of paper, right, with the homework, and I'm having you self-check your homework. And I'm going to need those today at some point. If you don't have yours for some reason because you left your Blue Day bag at home or whatever, just that's fine. Just have a conversation with me before you go. If you weren't here last class, see me at the end and I'll give that to you. And then I'll start checking your homework. And my hope is that I'll have time to check 2 assignments that I need to check from you now. All right, let's get into our notes. Start this again.